Some amateur videos that often provide misleading claims and content tout the virtues of high airflow machines and suggest they're better. This video explains the deceptive tricks being used to mislead unsuspecting viewers and is intended to help you learn to spot them so you don't fall victim. The fundamental problem is that amateur testers often fail to distinguish between fitted carpets and loose shaggy rugs. These have completely different backings, which dramatically affects the vacuum cleaner's motor limitations and the cleaning process. Backing provides the carpet base that the pile attaches to. Most fitted carpets have complex backing structures containing many layers and a range of materials. Many modern carpets incorporate protective water-resistant layers, which is very important to stop spills or moisture from wet cleaning methods penetrating beneath the carpet to the spongy underlay or subfloor, where it would be unable to dry before moulding and damage was caused. Watertight backing prevents airflow from underneath and thus limits airflow through the pile. Drawing air through thus requires good suction and a good surface seal, achieved with high-pressure motors and good cleaner head design, as vacuum cleaner manufacturers know. This is in complete contrast to shaggy rugs, which are designed to lay on a hard floor and be lightweight and possibly even washable. As such, they usually have a porous backing consisting of a simple layer of weave that the pile is sewn onto. It offers little resistance to airflow and allows large airflows to be drawn up through the lower pile. Rugs are completely different to fitted carpets, and cleaning behaviour is very different. The cleaner head is at low pressure, and so air flows into it. When the head is well sealed on the carpet, air can only flow in through the pile. Because air can't flow from beneath waterproof backing, air is instead replenished from the edges of the cleaner head. The carpet provides a resistance to airflow. The air closest to the head has less carpet in the way and thus experiences less resistance, so a greater portion of the total airflow is preferentially brought into the cleaner from those nearby regions. Deeper down, there's more carpet in the way and more resistance, so much less of the total airflow comes from there. This is one of the reasons why it's harder to clean deeper down, especially for deep pile carpets. Resistance isn't the same throughout the pile, but separating the pile can compensate for this. The second reason it's harder to clean deeper down is because pile is less well separated, making trapped dirt less likely to be freed. It's for these two reasons why the upper regions are cleaned better. The chance of dust being removed reduces as you go deeper down. Increasing motor power doesn't increase deep airflow by the same amount, and airflow near the surface increases preferentially. So even high suction machines with good pile separation have limits to cleaning performance with depth, and it has nothing to do with the vacuum cleaner, but is a property of the carpet itself. This is why dirt at the bottom is less likely to be removed in any given pass, and why deep cleaning is statistical and dependent on number of passes, as demonstrated in the videos in description links 1 to 3. The porous backing of shaggy rugs doesn't create that airflow restriction from underneath, so air flows both from the sides near the head and from beneath through the lower pile. Dirt particles are relatively much more easily removed from lower down, provided they're free and aren't netted. This is why testing on shaggy rugs can't be applied to fitted carpets. Shaggy rugs offer little airflow resistance and so allow a high airflow through the pile without the need for high suction. Machines which are designed to draw large currents of air without much suction will suddenly appear to be able to perform really well, as their suction limitations are conveniently avoided. Put a fitted carpet with high quality water resistant backing in the way, requiring high suction to overcome air resistance, and they struggle to maintain anything like the same airflow through the pile. And on rugs, because large airflow is coming directly from underneath, they bypass the difficulty of reduced airflow at depth. So implying that cleaning behaviour on rugs with high airflow is the same as on fitted carpets is not just deceptive, but simply wrong, as already discussed in the video with the fourth link in the description. Yet this is very commonly implied in amateur testing. Such videos either don't understand airflow behaviour through the pile, or are deliberately deceiving people to peddle a myth that low suction, high airflow machines are somehow better than the rest. Look out for it and don't be fooled. To help understand this by example, Kirby machines are often bragged about because of their high airflow at the open hose. But amateur videos linked to in the description show that simply putting a porous rug that offers hardly any airflow resistance under the cleaner head can reduce a 150 cubic feet per minute airflow to just 50. The tiniest resistance cuts off most of the airflow, yet this goes completely unnoticed. Even the brush roll apparently costs the machine 6 cubic feet per minute. You can imagine how much more would be lost on a highly resistive fitted carpet with waterproof backing. High suction prevents this scale of relative loss when it matters. Big airflows may be present at the open cleaner head on a Kirby, but put a fitted carpet there and it will drop at least as low as any cleaner, if not more. Those big airflow numbers are a big illusion in practice, and a tiny portion ends up through the pile. But amateur videos try to trick you into thinking it remains unchanged and stays enormous when on a fitted carpet. It's hoped you don't understand the importance of suction combating carpet resistance to avoid airflow loss. And as discussed in the video with the fifth link in the description, there's more to cleaning than suction and airflow alone, and cleaner head design has a far bigger impact. There are other differences between shaggy rugs and fitted carpets that mislead in amateur testing and artificially inflate the apparent performance of high airflow machines. The long floppy tassels on a shaggy rug make it relatively harder for any cleaner head to make a good suction seal. On high suction machines, that seal is required to draw optimum airflow through the deeper pile. As mentioned earlier, more air travels through the upper pile regions because there's less pile resistance, so air gaps will be where most airflow enters, generally bypassing the carpet. Brute airflow machines still pull large airflows through the lower pile, even with gaps on shaggy rugs, and so can get away with sloppy cleaner head design, but only on porous shaggy rugs. This is why rugs are favoured in misleading bedroom tests and con people into thinking such machines are better. Finally, another source of deception is the use of unrepresentatively large dirt concentrations in the shaggy rugs. This exaggerates apparent performance when combined with the other tricks, because more dust is freely available. It's important to learn to spot the three main sources of deception when low suction, high airflow machines such as a Kirby appear in amateur testing so you're not fooled. Firstly, make sure you spot the type of flooring they're vacuuming. A shaggy rug is not the same as a fitted carpet with waterproof, non-porous backing that restricts airflow. Secondly, long floppy tassels make for bad suction seals, which artificially inflates the performance of high airflow, low suction machines, unlike flat piles of a fitted carpet. And finally, the use of exaggerated messes also artificially inflates those two deceptions. I hope you found this video useful, and thanks for watching.